This is Mike Møller Nielsen from Java Code Geeks, and I'm going to teach you how to write clean, efficient Java code using the microservice approach. The word microservice is used a lot these days, but what does it actually cover? Why are those microservices so popular? That is exactly what we're going to dig into in this video right here. Complementary to this video, I have related links and articles in the description below. Take the time to like, subscribe, and hit that notification bell if you like these videos, because then you know when we have new things coming up. Now, without any further ado, let's get started. Before we look at some code, then let us try to think about what is a microservice. There are actually different interpretation of what a microservice should be, and there's different ideas about what a microservice should be. I have collected some of the ideas that are the most common, and also which I agreed to the most in my opinion. So you might find other definitions than the definition I'm going to show you right here. The first point is that it needs to be non-monolithic. In the old days, we created one application to rule them all. That means that usually you would start with creating a customer system. Then this customer system would also be extended with a invoicing system, and this system again could be extended with a sales module, etc., etc., etc. So that means that you got one huge application that just grew and grew and got bigger and bigger. And the downside about this is that if you wanted to update or change a part of the system, then you actually have to redeploy the whole application, and you also had to test the whole application. And if you had a third-party system that wanted to integrate to this application, then it was one huge thing. So it was difficult to maintain this application, and it was also difficult to test it, because you had to test the whole thing whenever you wanted to just change a small bit of this monolith application. And that's where microservices comes in, because microservices, they have these traits, if you will. They need to be easy maintainable. That means that they need to be configurable, maybe with external configuration, externalized configuration, and this again means this could mean environment variables. And again, this means that the developer would not have access to secrets. Maybe the developer does not have access to the database credentials or to the cloud credentials. These could just be injected when the Docker container is up and running as environment variables. That is a good way to do it, by the way. It needs to be easy testable, so that means that we could use something like like a JUnit 5, for instance, or testng if you prefer that. It needs to be easy to deploy, and here we could take use of the cloud, for instance, Amazon, Google, or Azure are some of the largest clouds out there. And then usually a microservice is handled by a small team. That means that this small team actually handles this microservice, and they can decide, and they have the responsibility of what kind of technology that should be used for this microservice. And again, the whole trick right here is that we want to divide business problems into smaller technical applications. So we only need to take down smaller applications and maintain smaller parts of the application when changes will come from the business. So the whole purpose right here is to solve a specific business problem. It needs to be loosely coupled. That means that it should not be. It should be possible to redeploy a new version without redeploying other applications as well. And this is where REST comes in. So a lot of microservices actually use REST, and this means that they will expose REST services through HTTP, and they will also communicate with JSON and maybe use the JSON API to convert objects into JSON and JSON into objects. A microservice should also be stateless, at least the REST services for the microservice should be stateless, and it should also have its own database. It should not share its database with 10 other microservices, for instance, so they could by accident or maybe on purpose suddenly access each other's data structure. All communication between the microservices should happen through the REST, to the API, to the REST API, and no direct contact to the database or the data structure from another microservice. It should be self-contained. That means that it should have all the things that they need. That could be, if it need a web server, then it could have that web server embedded inside it. In the old days, we would have a web server deployed somewhere, and then we would create a WAR file, and then we would place that WAR file onto that web server. Nowadays, the web server is actually a web container, which is then contained inside the application. It's just a part of the application that is just the web layer of it. And usually it is containerized. That means that we use Docker or Kubernetes in order to build, and then we will place this, for instance, a jar file onto this Docker image or onto this Docker image, and then we will just spin this up in production. And the benefit with this is that when we try something on our own machine, in our own environment, then it will work the same way when it goes to production. So there are less surprises when code goes into production. So that is a very good way. So this is the kind of the consensus microservice definition that most people would agree to. At least this is, in my opinion, the microservice definition. You might find smaller variants of this drawing right here, and smaller variants of the definition. Now let us look at some frameworks, because especially in the Java world, but actually in regarding all programming languages, there are frameworks that can help us and support us when we want to create a microservice. In the Java world, we have three very known frameworks, and those are called, the most famous one is Spring Boot, so that is the most used one, and then we have Micronaut and we have Quarkus. The Micronaut framework is actually created by some of the Spring people behind Spring that actually went from the Spring project, and they wanted to create something that was a bit more lightweight and that could actually run on the Graal VM, and that means that it could start up faster, and it could be compiled as a native executable, and that means that it will be compiled to the system where it actually runs. And this gives much smaller startup times and lower startup times, and it also what it actually does is that it actually loads the whole application into memory from the beginning, and then so there's no lazy loading, and reflection is not a good thing when you are dealing with the Graal VM. Also because the Graal VM actually optimizes, and it also removes dead code. So if you have some code that is not used anymore, then the Graal VM will actually remove it when it is compiled and optimized. Quarkus is kind of the same. That is even more lightweight than the Micronaut. So there are even smaller packages in the Quarkus framework. And you actually do not get a main. You do not get a class with a main method when you create the default application in Quarkus. You need to use Maven to actually start Quarkus. But we will look into that in just a moment. First of all, let us look at the most used framework, and that is Spring Boot. And to all of these projects, there are excellent support and documentation online. For Spring, you can just go to spring.io, and then you can get started, and you can get some good tutorials in there, and there is also good in-depth documentation if you have a specific problem. Also, if you search the internet for solutions for all of these three frameworks right here, they're well supported. So, and Stack Overflow has a lot of problems, and there's a lot of solutions for problems to these three frameworks right here. So Spring.io, that's where the Spring framework is located, and then we have Quarkus that is located at Quarkus.io, and Micronaut is located at Micronaut.io. All of these three systems, all of these three frameworks, they have a way to get a startup application very easily. And if you use IntelliJ, which I'm using right here, then there is support for these three frameworks. If you press File, New Project, right here, and then you can see here there's a Spring initializer right here, and that actually uses the official Spring initializer to create a project from scratch. So it's a kind of a template of how to actually create a project. First of all, we can choose between Maven and Gradle. Usually, I actually prefer Gradle because it's there's a little bit less lines to read and to deal with. But for this demonstration right here, I've chosen to use Maven for all three projects nowadays. In this video right here. And then you can choose the language, and you can choose between Java, Kotlin, and Groovy. I really like Kotlin myself, I must say, because you can actually create your whole backend in just one file. If you have a very small backend, at least, of course, it's not something that could be recommended that you create your whole application in one file, but it is actually possible with Kotlin if you want to do that. I have used Java for all these three examples that we are going to see in this demonstration right here. I have chosen Java 11 because that is the long-term supported right now. Soon we will get Java 17, and then Java 17 will be the long-term supported. I'm using SDK 16, but that is still okay because it will, my Java code will be written in, with compliance to Java 11. Then the packaging should always be jar, unless you have a very good reason for using a WAR file. That's actually a slogan, make jars, not wars. And there's a good reason behind that. That is actually that then you have this self-contained jar file that you can then easily put inside a Docker container, and then spin up your Docker container, and then it just works from there. With the WAR file, then you need a web application besides that. So it's much easier by just using the jar file. Then I press next right here, and this is what I really like about these frameworks right here. They are modular. So that means that, first of all, I need to choose a version for Spring Boot, and the current version right now is 2.5.0. And of course, if I feel if I feel like a daredevil, then of course I can also use some of the snapshots that are currently under development. I would not recommend you that unless you are unless you're very experienced with the framework and you really need some new feature that is just about to be developed, then you can use the snapshot. But if you are new to microservices, then use the stable version instead. And here I can just choose the modules that I want to. I want to use Lombok because then I save then I don't have to type as much. Then I will get a lot of boilerplate code created for me, like getters, setters to string methods on top of my Java classes. Another thing I want when I'm dealing with Spring Boot is I want the web module also applied and installed. So then I just tick off these two. Let's say that I also wanted a Mongo, I wanted to connect to a Mongo database. Then I would actually just write Mongo, and then I could tick off Spring Data for MongoDB, and then I would get the right dependencies placed inside my Pom.xml file or my build.gradle file if I use Gradle. So, and I think this is awesome because this gives me a good start. I don't have to go hunt for the dependencies. I just know when I press on the finish button right here, then I will get all the dependencies that I actually need, and I know that I will actually have a working application. Of course, sometimes then I could also add my own dependencies as usual. So if I have extra dependencies, then I would just add them right here. And it's actually, there's not a lot of dependencies right here because Spring actually keeps track of which versions that I need, is as long as I just say that I want to use Spring Boot, which I'm saying right here. Here I have the plugin, which actually handles all of the underlying dependencies that my Spring project uses. You can see here I'm not giving any version to my Spring Boot starter web artifact, for instance. This will all be handled by the plugin, and since I chose since I have this version right here 2.5.0, then all of the other versions will just be chosen, so they actually work together. And this just helps me a lot as a developer. I do not need to think about my dependencies when I start up a new project. I get something else. I also get this application right here. This is also part of the template. I get this application class right here, which is just a class with a public static void main inside it, and this is actually where my Spring Boot application starts. So if I want to run out my application, I can just press the green arrow just to the left of my main method right there. Before I do that, then I want to show you that I've created a package with a spaceship inside it. This is my spaceship. And as you can see, my member variables, they are private, but that doesn't matter because when I annotate with add data from Lombok, then my getters and setters will automatically be created. I will automatically get a toString method created, and also the hash code will also be written and created from these member variables right here. Then I've created an all-args constructor. That means that I'll get a constructor matching all of my member variables right there. Then I've created a REST controller because I wanted to create a REST controller in this microservice that I'm creating right here. I have in the top of the file, I'm annotating with add REST controller, and you can see that this comes from the Spring package. And here under that, then I have a request mapping where I say which prefix endpoint should I have to all of the rest of the endpoints. This means that now I will actually be in this context right here. I will be in the /space context. And that means that when I create more endpoints later on right here, then it will actually all of these will actually start with /space and then /ship like this. And then I don't need to write space in front of all of these endpoints right here. And that is a very nice way to do it, because then if I want to change this from space, it could be to something else like outer space instead. Then I just need to change it one place, and then it will actually be applied to all of the endpoints in this class right here. I'll go back because I've created some nice curl scripts that we will use in just a couple of minutes. So of course I'll go back to the space prefix right there. Then I've created this static spaceships array right here. And this is just an array where I add one default spaceship where the captain is Mike and the fuel percentage is 50%. Yeah. And I'll just go to the left side. Let me just jump right there, because I want to show some more code right here. And here we have and we can see here I'm annotating this method with get mapping. So that means that if I send a HTTP request with the type get to this endpoint right here, /space/ship, then this method right here will then be executed. That will be called. And then it has a return type right here. That is a list of spaceship. And then what actually happens is that the JSON will actually convert this list of spaceships to the JSON format. And we will see this in just a while. And what I'm returning right here is actually the static spaceship list that we have up here. Then I have created a post mapping, where that means that we can actually post a spaceship to this endpoint right here. And I'm using JSON to convert the JSON which is posted to this endpoint, and I'm converting that into a spaceship like this. Then I add the spaceship to my static list, to my static private list right here of spaceships, and then I return the whole list so I can see what the result is after I created the spaceship. Then I've created a delete mapping. This means that now I'm deleting all the spaceships with the name, where the captain name is this variable right here. That means that I'm using a path variable or path parameter, if you will. When you deal with Spring Boot, then it's actually called a path variable. In other frameworks, it's called a path parameter. And that is, you can write it here with a curly bracket, and then you need to name it something, captain in this situation right here, and then a curly bracket ends. And if you make sure that your argument right here matches the name of this argument right here matches the path variable, then you don't need to give any name for the path variable. But if they are different, then of course you need to give it as an argument to the path variable annotation right there. So that means that now they do not need to be the same. I could call it captain of the ship or something like that, of course, and then I need to refactor my method also. So I'm not going to do that, but that is also possible. I'm just going to leave it here. So that's also okay, both to say that this argument right here should be mapped to the path variable right there. And again, I am returning a list of ships, and the reason why I'm doing that is because then I can see the result after I have deleted. First I actually filled out all of the spaceships that has that the captain name equal to whatever we get in, and then I say ships.remove like this, and then I return my ships collection right here. And again, of course, this could also be stored in a database, for instance, a Mongo database, if I wanted to. I just want to keep this example simple right here. So that's why we are just updating a private static list right here. Now let us try to run this application, and it is very easy to run. We will just press the run button right there. So that means that we are actually just running the static void main, and then our Spring Boot application will start up. Here's our Spring Boot application. We can actually see here we have this Spring logo right here. That can be replaced if you create a banner.txt file. Then you can actually create. Then you can make your own. Your own banner instead of having the default banner as we have right there. And we can see that the application started up on port 8080 like that. And we can also see how long it actually took. It took like 3.5 seconds to start up the application right there. I want to go out in a terminal now, and now I am going to swap back to the right side right there, because I've created a script folder. So that means that where I have some curl scripts. I have a curl script that lists lists all of my spaceships. And I can do that by just curling. And the curl, that is a HTTP client utility for Linux that you can use. But you can also use something like Postman if you want a nice UI to send HTTP requests and get the responses also afterwards. So we have a list. This curl command right here will actually list all of my spaceships. And then I have a create spaceship right here. And I'm using the backslash right here to have a multi-line curl commands. That's why you have the backslash right there. And here I'm using the method post when I want to create. And then I need to say in the header that the content type is application JSON, or else my Spring application does not know that it should actually take this JSON and then convert it into a spaceship object. So you need that header on top of your request. And this is then the endpoint. Again, it's space/ship. And then I have my delete ship curl, which is right here. So curl and then -x for the type. And then the type is delete in this situation. And here I have space ship, and then I have set the captain variable to Mike. So that means that the spaceship with the captain Mike will be deleted when I call it. Let me go to my script folder right here. Curl list ships like this. Here I can see I have my default ship, which is Captain Mike. Let us try to create a ship. Curl create ship like this. Now I have two spaceships because I just created one spaceship right there. So now I have two spaceships. This is the second spaceship that I created. That is now I have Torbjørn, a spaceship that is where Torbjørn is a captain and one where Mike is a captain. Now let us try to delete a spaceship. Delete. So now I deleted the Mike spaceship, and now I only have Torbjørn, the Torbjørn spaceship left. So that is how easy it is to create a microservice with the help of Spring Boot. Let us try with Micronaut, which is much like the Spring framework, because it is the same people that were behind the Spring framework. They just wanted to create something that was supported better by the Graal VM, and thereby it was possible to create this native executable so it can start up much faster. And they also wanted to make it a little bit more lightweight than the Spring framework is today. The Spring framework has a lot of options and a lot of possibilities, but you can see when you create the jar file, it actually gets quite big when you create that jar file. So the purpose of both Micronaut and also Quarkus was to try to create lightweight frameworks that started up faster and also was a bit smaller when you build them. Again, it's actually the code is almost the same. So the way that I created this Micronaut project was to choose a new project from IntelliJ, and then I chose Micronaut like this. And again, I have this nice UI where I can just choose whatever I want, how I want to create my project. If I want to use Gradle, then I could just choose Gradle right here. want to use Maven, which I did in this situation, I just tick off Maven. And if you want to try Kotlin, and if you haven't tried Kotlin yet, then I would definitely recommend that you try that one day. It's a very cool language. But for this demonstration right here, I chose Java and I chose JUnit, and then I press next. And here, then we need to tick off some dependencies. I chose Tomcat just because I know that web server well. And then there's actually also Lombok, Project Lombok for Micronaut, so I also ticked off that. And then I pressed finish, and then I got this project right here. Again, just like with the Spring project, then we actually have a main. So we actually have this public static void main right here where the application actually runs from. This is the entry point of the application. And then I have created a spaceship. I've created a spaceship class right here. And again, I have a captain and fuel. I could actually copy paste this code from the other Spring Boot project. So, and that's actually also what I did when I prepared for this video right here. Then I have the spaceship REST controller. Now we have some small changes from the Spring Boot project. Instead of REST controller, then it's just called a controller. And I do not need to have a request mapping line. In the other project, I had a request mapping line underneath my REST controller annotation. Here, it's actually embedded inside the controller where I want to start, which prefix do I want to apply to all of these endpoints that I'm creating right here. So that is the main difference between the REST controller and the controller inside the Micronaut framework. Again, I created a list of spaceships like this with a default spaceship, which where Mike is a captain of the default spaceship right there. And then again, here I have my get mapping. Instead of the annotation named get mapping, then in Micronaut it is just named get at get. So they have shortened out the annotations a little bit, and all of these annotations come from this package right here, io-micronaut.http annotation. So the package is just Micronaut instead of Spring Boot, or else how we use them are actually a lot alike. So here we have the get mapping, and again the code is just like we saw in the Spring Boot example. We return a list of ships, and then the Jackson is converting this list to JSON. That we can then get from our HTTP client, and in our situation it's a curl script again. Again, here we can post a spaceship. That means that in this situation, we do not need to say request body. We just say at body. And again, the Micronaut guys have just shortened out the annotations. So instead of request body, it's called body. And again, here we give the type of the argument of the variable right here, and that is a spaceship. And we add the spaceship to our list, and then we return the new list afterwards. Then we have the delete endpoint in the end right here, and then again it looks almost like it actually looks almost like the Spring Boot version. Here we have at delete instead of at delete mapping, and again we use curly brackets to say that this is a path variable. And again we actually use path variable just like with Spring, and it just comes from another package than in the Spring situation right here. Let us start up this application. Let us just make sure that the other application has been stopped because they use the same port. So I'll press the stop button right there. And then this is the Micronaut. And again, I go to my terminal. Just clear my terminal again here. And I'm inside the script folder right here. So first we need to start the application first. Let us just do that. And I'll run my application by pressing the little green button. And then you get a Micronaut run configuration, which you can edit up in the top right here. The cool thing about both Micronaut and actually all of the frameworks is that you can actually create profiles, and that means that you can have them use different configuration arguments in different environments. Under resources, both in the Spring Boot project and also in the Micronaut, you will actually get an application.yml or an application.properties file where you can place variables that can be used inside the application. So that means that it's actually the same application that runs in development, which also runs in production. It just gets some other another set of configuration, so it behaves differently in production, of course. So now we started up. This is our application right here. Now let us try to run the curl scripts against them and see what will actually happen. So curl list ships. Again, now I have my default spaceship, which is Mike. Let us curl create ship like this. Now I create the Torbjørn ship also. And now I also want to delete curl delete ship. And now I just deleted the Mike spaceship right here. So it works much like the Spring project. So if you know, if you have deep knowledge to the Spring Boot project, then it will be easy for you to swap and use the Micronaut project. And the benefit of using the Micronaut project is, of course, that it can be that it can be optimized, so it can start up much faster than the Spring Boot project. I must say, the Spring Boot project actually has something under development. They have something that they call the native module, which is under development, and the version right now is 0.10 something. And the purpose of that module is actually to make it to make it support the Graal VM. So at some point, Spring Boot will also be enabled to compile that for the Graal VM and then thereby start it up very fast. And this new native module that the Spring Boot guys are developing, they will also support build pack. So it will actually automatically create the Docker image that is needed for this application to support Graal VM. And that means that it will take a little bit longer to build the application, but it will start up much, much faster, like 0.1 second or below that even. So that is very exciting, I must say. The Quarkus microservice. This is a little bit different. Again, you can create this project in IntelliJ by pressing File, New Project right here. And then you can choose Quarkus. You can choose Maven as usual, Java as usual. And of course, you can also choose Gradle and Kotlin if you want to try those out. And you can tick off whether you want the example code or not. And that is because you do not get per default you do not get a main method with the Quarkus framework. You need to start it with either Maven, Maven or Gradle. So that means that there's no main method, no main entry point with Quarkus. And again, the purpose of Quarkus is to make it more lightweight. And because it's more lightweight, that means also you have more options. So I would say this is a bit more advanced, this framework, than the other two frameworks. The other two frameworks are easier to get started with. The Quarkus, then you need to know a bit more about what you are actually doing and which dependencies you actually want. And in this situation, we have created something called REST Easy. And we want the REST Easy Jackson API for this demonstration right here. You can also tick off the REST Easy Jax RS to create some REST services. Then you press finish. I just press cancel because I already did this. And then you will get this nice POM file right here, where you will get some dependencies. You will have the REST Easy, which I have right here, and there's also JUnit 5 right there. And then that is the Jackson. You need the Jackson dependency also, because then you can convert objects into JSON and also JSON into objects. Let us look at the code, because it is a little bit different here. Again, we have an application properties where you can set your properties and you can create different profiles or environment by creating more application properties files that then have the environment name inside them, like application minus production, for instance, or application minus development, etc. And the only file you get, because I ticked off example code, then I will actually get this example resource right here. And I will not get any application class with my main method in it, as I'm used to with the other two frameworks. So that is the main difference when you start up, when you start up this workspace right here. Then the way that we actually create resources is actually by, it's not called a REST controller or controller like it is in the other two frameworks. It's just called, you can just name it a resource, and then you can annotate this with path, and this comes from this package right here, Java XWS for web service, and then IS for REST right here, and then path right here. So it comes from a whole other package than the other the other frameworks. The other frameworks, they have made their own annotations. In this situation right here, I have /hello. So that will be the context. and then I do not have any extra path right here. That means that if I just call the slash hello endpoint with a get request, then I will get this returned right here, and this is just plain text. You can see right here produces and then text plain right here. So and this is already created for us. This class was already here when I started up this workspace, when I was done with the menu. Yeah. So let us look at, again, I've created a spaceship. This time I've not added Lombok because Lombok is a little bit more difficult to add with Quarkus. It's not impossible. You just need to make sure that your Lombok dependency is one of the first dependencies. It should be the first dependency inside your Pom.xml file. But if you want to make sure that your Quarkus application works, then leave it out to begin with. But if you really want the Lombok dependency, then just make sure that it is located first. I've left it out for this demonstration here just to keep it simple. And since I've left it out, that means that I've created, I actually made IntelliJ. If you press Alt Insert after positioning yourself after the class name, then you can actually say that it should create the getters and setters, and it also should create some constructors like this. Alt Insert after you place the cursor after the class name, and that's exactly what I've done. And then IntelliJ actually created my constructor right here, which is a constructor that has both member variables and then a default constructor that does not have any member variables there. Then I have a getter. Then I've created a getter and setter for both fuel and the captain. And as you can see right now, some of them are gray. That's because they're not used in this simple example right here. Then I've created a spaceship resource. I've named it resource instead of REST controller because that is just the naming convention when you are dealing with Quarkus right here. Again, I have a path which is /base. So this is my context. I have my spaceship just like before. I've copy pasted all of this code, and then I could just change the annotations for each method. That is how I created this class right here. First of all, this is which HTTP request that this corresponds to, and this is get, and then I can change the path. That means that I can add extra part of the path. That means that if I go to /base and this /ship afterwards, then I will actually get a list of the spaceships returned. And I did not have to add produces application.json. I just wanted to add this so you can see that you can actually choose what kind of content should be returned. You can choose that in the add produces annotation. And then we have the posts. Again, path is set to ship, and then I can post a spaceship. And in this situation, I do not need to write that this is a request body or anything. That will just be inferred. I also have a delete right here. This is my delete method. And again here, then I give the captain as a path variable or path parameter. And here it's actually called a path parameter when you're dealing with Quarkus because it uses the Java VSIS annotations. And in this situation, I write captain. That means that it will map captain, the captain variable that I have in my path right here to whatever variable I would have right here. And in this situation, I've named it captain, so it has the same name. Then I am, again, fetching out all of the spaceships that has that name, where the captain name is equal to that, and then I remove that from the spaceship there. So the code is, it should be very familiar now. Let us try to run the application, because how will you run this application? You actually get a run configuration up at the top right here to begin with. That run configuration, that is how you would actually start the application. Let me just make sure that we stop the application. Yeah, we did that. That's Micronaut right there. So we stopped the application just before. So let us go back to Quarkus right here. So the way I start the application is actually by using Maven, and you can actually see how it actually starts. If you want to run it manually in your console, then let me just see here in a minute or so, it should actually start up. Here you can actually see it. It runs Maven Quarkus :dev. And that's because this is for development purpose. The purpose right here is development. So, yeah, so you use Maven to start it up, or Gradle if you use Gradle, of course. And there's, the output looks a little bit different, but not much. And of course, you can also configure the banner, just like with Spring Boot and also with Micronaut. So it's actually it should be running now. Yeah, you can actually see that it is running. It took 1.8 seconds to start up, and it's listening now on port 8080. Of course, the port can be configured to whichever port you want to use. Again, I've used I have created some curl scripts again. So let us go to scripts. I'll just list my curl scripts right here. First, I've created an extra curl script, which is actually hello world, which is right here. Let us try to use that first, and then we get hello rest easy. So that comes from that was the response from the example resource that we got by default. Then we have curl create ship right there. Now I created an extra spaceship, and then we have the delete ship right there, and then I delete Mike, Mike is a captain, and that's actually it. So I hope, this was the walkthrough for these three frameworks: Quarkus, Micronaut, and Spring Boot. I hope you liked this video. If you did, then please take the time to smash that like button and hit subscribe to the channel and hit that notification bell, because we have a lot of cool things coming up. Bye.